Section 5.5 is called RHL, and we're just going to add another theorem or another postulate for your proving triangles toolbox. You have SSS already, you have SAS, you have ASA, you have angle, angle, side, and now you're going to be adding RHL to that. So before we talk about what RHL is, let's take a step back, all the way back to the first unit when we were talking about proving triangles congruent. And we said that we can't do AAA and we cannot do the bad word. Well, let's talk, just take an aside, let's talk briefly about why we cannot do SSA, the bad word. Okay, we're going to talk about why we cannot do side-side angle, okay, or the bad word. And so I'm going to take a look at this triangle that's up on top here, this first one right here. And I can see that I have an angle that's fixed. I have a side, AB, that's fixed. And now my side that comes right after my side, right, the SSA, if I take my side right here, I create a triangle that looks like this. However, this angle up top here, right here, is not a fixed angle. And so I can take this side BC, and I can actually, if you pretend there's like a hinge right here, I can actually swing side BC all the way over to right there and create a different triangle. So the first triangle we created was this one down at the bottom left. That's this triangle. And now when this side swings across this way, because this angle is not fixed right here, it becomes an entirely different triangle. And hopefully you can see that neither of these triangles are congruent to each other. Yet they have same side, and same angle in that order, but yet the triangles are not congruent. And so side-side angle does not work. Now, the one situation where side-side angle actually does work is as follows. If this side, BC, was a little bit shorter so that it actually was more like straight up and down like this, like an altitude, and it formed a right angle here, hopefully you can see that it's not going to swing back and forth anymore. It's not going to swing back and forth on this hinge. It's just going to hang straight down. And so you only end up with one case here, one situation, this situation right here, okay, when that side is forming a right angle there. And that special case is what we call RHL. So let's talk more about it. So RHL is just a special case of the bad word SSA. Okay, and basically the conditions are you need two right angles, you need hypotenuse congruent to each other, and you need one set of legs congruent. Okay, so let's try it in an actual problem here. So BD is perpendicular to CF, so I have right triangles here and here. GE is perpendicular to CF, right angles. CE is congruent to DF. Hopefully you can see that the overlapping segments. From that, you know that CD's got to be congruent to EF. And BC is congruent to GF. So I know that this is congruent to this. It looks a whole lot like these triangles down here are the ones that I'm going to be proving congruent. Hopefully you can see that. And once I get that, it looks like if I want to prove ACF isosceles, I just need the base angles C and F to be congruent to each other. So let's write this out. I need step 1, I need the perpendicular lines. That's going to be given. Step 2, I know that angle BDC and angle GEF are going to be right angles. That's because if perpendicular, then right angles. Step 3, now in previous proofs, we would say that right angles are congruent. You do not need to say right angles are congruent here. Okay, so for RHL, the condition you need is just that they are right angles. So I'm going to go with CE congruent to DF in the next step. That's given. And we know that we had mentioned earlier, since those are overlapping segments, I know that CD has got to be congruent to EF, and that's going to be by subtraction property. Step 5, I know that that's going to be, so here's my R, and here's my legs, right? Those are legs. And I know I'm given that BC is congruent to GF. That's my hypotenuses, hypotenusae. So that's going to be just given. Step 6, I know that the triangles now, I can prove that BDC is congruent to triangle GEF, and that's going to be by RHL from steps 2, 4, and 5. My follow-up to that, of course, will be a CPCDC step. Angle C is congruent to angle F by CPCTC. And then my last step will be that it's isosceles. Triangle ACF is isosceles because if my base angles are congruent, then I have an isosceles triangle. Okay, and that's it. I think we'll jump to the back side and try maybe 1 or 2 more of these proofs. Okay, I want to do 2 proofs on the back side here. This first proof is a circle proof. So you're given circle O, which tells you that O is at the center of the circle. Anytime you have a circle proof, you're looking at radii congruent. You have a right angle here and right here because of these perpendicular statements. You got a reflexive property down the center here. Okay, so if you look at this, it looks like I can prove these 2 triangles congruent. And I take a look at this and I go, oh, it's the side-side angle, but it's the special case of the side-side angle because I have the right angles here and here. So here's my R's, here's my legs, and here's my hypotenuse. And remember, again, so as I'm writing this thing, circle O, step 2, YO is congruent to OZ, radii are congruent. Step 3, I'm going to use the perpendicular here. Step 4 gives me the right angles, so angle OYX and angle OZX are right, and that's going to be if perpendicular then right. And here's the step that you do not need to do. Okay, I can't emphasize this to you enough. When you're doing RHL, you don't say that the right angles are congruent as a next step. Okay, that is a step you do not write in there. You're going to get points off, so make sure you put a note, put a star next to it. Okay, make sure you know it well. Next piece here, of course, is that OX is congruent to itself. Reflexive property. And then I can prove the triangle is congruent by RHL, so OYX is congruent to triangle OZX by RHL. Steps 2, 4, and 5. And then I can say that YX is congruent to ZX by CPC2C. Okay, let's try one more proof here. And this one I may not write all the way out. I'm just going to probably just do it on the diagram. So HY is congruent to LP. PH is an altitude and YL is an altitude, so it's drawn perpendicular to the opposite side. And hopefully you can see here that the information I have here is going to lead me to the overlapping triangles. Well, actually, I could do these triangles too, but it's not going to be as helpful. I could do the bow tie triangles. What I'm going to focus on, though, is these overlapping ones. So if I can get this triangle congruent with the other overlapping one, then that'll be helpful. Okay, because once I get those two overlapping triangles, I know that the entire bottom base angle is congruent to this bottom base angle and its isosceles. So then I can say that the entire side's congruent and this side's congruent, and then I can do a subtraction. Let's write this out. Okay, so step 1, HY is congruent to PL. That's given. That's going to give me my legs. Step 2, I have altitudes. Step 3, because I have altitudes, I have right angles. So angle YHP and angle PLY are right angles because an altitude, actually I probably need a step in between here. I'm going to need a step 2.5. I'm going to need to say that PH is perpendicular to HY and PL is perpendicular to YL. So my step 2.5 is going to be altitudes are drawn perpendicular to the opposite side. And once I have the perpendicular, now I can say that if perpendicular, then right angles. Once again, I do not want to say that right angles are congruent here, not when I'm doing RHL. So I got my legs, I got my right angles, and then my hypotenuse is going to come from YP being congruent to itself. So that's step 4. Reflexive property. Step 5, I know that triangle HYP is congruent to triangle LPY by RHL, steps 1, 3, and 4. Step 6, this is what I had said was the reason why we chose these triangles, is to get these base angles congruent to each other. So angle AYP is congruent to angle APY. That's just going to be CPC2C. Okay, those are the bigger angles that are not the right angles of the two overlapping triangles. Step 7, I know now that AY is congruent to AP, and that's going to be because if angles, then the sides are congruent. And keep in mind that I already know that, so these sides are congruent to each other. And keep in mind that at the very beginning, we know that HY is congruent to PL. So just by subtraction property, I know that AH is congruent to AL by subtraction property. And I'm done. So hopefully you're all set with RHL. Just one more tool for your toolbox. And that's it. Let you try some problems now.